Hi guys, this is going to be a quick video just showing you how to do a line of best fit in LoggerPro. So you can see we have a bunch of data right here and a lot of data points. And one of the things that we're usually trying to find in physics with data is a mathematical relationship. So I'm going to start out with this velocity graph that I have right here in the middle. And we can see that the velocity graph right here looks very linear. When the cart hits the bottom of the track, we get a little bit of a bump, but in between, we have a prettier linear relationship. So if we're trying to find the equation that models the velocity as a function of time as the cart goes down the graph, it's most likely a linear function. So one of the things I can do is I can choose one of these lines just by highlighting it like this. And then if I come up to the top of my LoggerPro, you can see that there is a button for linear fit. So anytime you're going to want to find the equation of a line, you can highlight what you want and then click that linear fit button. And can everyone see that what I get is a line and I get a lot of information for that line? So it's telling me it's a linear fit right here. This is in the relationship of velocity equals mx plus b, because we're talking about the equation for a line. M is going to be the slope, and they're giving that to me in 0.2515 meters per second, because remember, the slope is how the x-axis changes with regard to the y-axis. So this is how many meters per second I'm changing each second. The y-intercept is going to be negative 0.9 meters per second. So this is really extrapolating this line down here to the y-intercept. And it gives me a correlation and an RMS value, which I'm not really going to worry about right now in this class. So there's a couple things that you might want to do to change this so you can display it well on your Google document that you're handing in. And if you double click on this box, you're going to be given some options for what you want to display. So first off, we always want to think logically and think about how accurate we can really be. Think about whether or not you really know the speed of that car into the 10,000th of a decimal place. And I'm going to say that for this particular one, I wouldn't give myself anything more significant than 3 sig figs. The other thing I can do is the appearance of this I can change by going ahead and clicking on the appearance, and I can change the font. So let's say that this wasn't large enough for you to see when you're putting it on your Google Doc. You can make these fonts bigger and smaller so it's easier to see. You can also change the colors. And then you can also change what we're going to show. So uncertainty is something that we're really not going to worry about in this class. So we're going to make sure that's always clicked. And we're not going to worry about using the entire range because I told it the range to use. So if I say OK, you can see it changed the number of significant figures. And this is just a little closer to what it is that just makes sense for the lab that I'm doing. Now, the next thing I might want to do is copy and paste this graph so that, oops, sorry, I didn't mean to double click right there. Copy and paste this graph into my Google Doc. And one of the things you're going to want to be careful when you do that is you really do copy and paste a graph so it's easy to see. So one of the ways we can do that, making our graph a little easier to see, is resizing it. By resizing it, we make the graph itself smaller, but these axes and the numbers that go with them don't get resized at all. And so when it's pasted into our Google Doc, it's a little easier to see. One of the things that you're responsible for is always presenting your data clearly. So do make sure that when you paste a graph into that Google Doc, you can see what's there. The next thing I want to do is think about, and I'm just going to undo this so it goes back to where it was. There we go. I'm going to undo all that. Okay, the next thing I want to talk about is a curve fit, because if you look up here at the position versus time graph, it's clearly not linear as we're moving up and down the track because we're changing the velocity, or therefore changing the slope as it moves. So instead of doing a linear fit, I'm going to need to do a curve fit. So the first thing I'm going to do is the same as what I did before. I'm going to want to highlight the portion of the graph I want to curve fit. And I'm actually going to be careful that I don't get too close to the point where the car hit the end of the ramp, because I'm not quite sure exactly where in here the car hit the ramp. And so if I accidentally choose part of it, it's going to change my graph. So For getting a curve fit, you're going to go up to the Analyze menu, and you're going to come down to Curve Fit. Now, linear fit works the same way as we did before. There's just a button to use it, so you don't have to use the menu. And I'm going to choose Curve Fit, and I'm going to get a lot of options there. So first off, it's telling me the section that I'm choosing, and then it has all of these equations that could work for a curve fit. The problem is I need to make sure that I'm choosing the right one. So if you look, I have a cosine equation right here. And if I choose that and I say try fit, it's going to fit a cosine function to this. But just because the program can fit a cosine function doesn't mean that a cosine function is appropriate. Now, one of the things we learned is that when you have something accelerating at a constant acceleration, the position versus time graph is going to be a quadratic. And so instead of choosing cosine, I'm going to choose quadratic. And then I'm going to come right down here and I'm going to hit try fit. And what this is going to do is it's going to show me the fit right here, show me the quadratic that it fits. It's also going to give me the variables, the a, the b, and the c term for that quadratic equation. So you can see those are all right here. If that looks like it's good to me, I'm going to go ahead and hit OK. And this is going to give me that same box that I got for the linear fit, but now what it's doing is it's giving me information for the quadratic equation. Now you can see that there's a couple things in here that I don't really want. I really don't want to know about the uncertainty. This is something the computer calculates, and it's not the way we think about uncertainty. So I'm going to double click again on this box, and I'm going to say, don't show me the standard error. That's the uncertainty. I'm also going to only show 3 significant figures because that's really as sure I feel like I can be about my data. So I'm going to go ahead and I'm going to say OK again. And I get a little cleaner of a box to have on my graph. I can now resize this graph, and I can paste it into my Google Doc. So maybe this looks good with moving this down here. And so one of the things you always want to make sure is that when you're resizing a graph to put it into your Google Doc is you really resize it in a way that displays the data well. You can see that what I've done is I've resized this so I can see the line of best fit. I can see all the variables that go with that, and I can easily see the axes. This is now ready to cut and paste right into my Google Doc. I hope this was helpful for you guys. If you have any questions, please don't hesitate to ask.